Hello everyone. Our MQP is called Real-Time Feedback in Coding-Based Games, and the game we made is called Coding Through the Ages. Hi, my name is John Amaral.
Hi, my name is Shuxing Li.
Hello, my name is Pellela.
Visual annotations in programming environments can make it easier for programmers to understand the execution of their code, as Brett Victor's example here shows. These types of visuals can provide a more enjoyable and understandable user experience within a program, such as with Professor Roberts' live coding language Gibber. For this project, we decided to apply this concept to another medium by introducing inline visual annotations into a coding-based game to see if they could help players manage multiple different tasks at once. The game takes place in a window that looks like a computer terminal, like a lot of older text adventure games. It was made in JavaScript, and it uses the Code Mirror library to create a mini programming environment in the web browser. The goal of the game is to make decisions to specific events throughout time while balancing 6 different resources, which are hunger, food, security, population, military, and science. This can be done by entering commands into the window, such as the choose command with the desired option to make a decision in response to an event, the eat command to eat a piece of food and keep your hunger bar high, and the secure command, which will increase your security and reduce the chance of random decisions being made. The different visuals within the game, including the bar graphs for each resource and the line at the bottom for the timer, serve to help the player better understand how the game is changing as they play. After a few decisions, the player will unlock the Automate command, which will allow them to write their own functions that will run automatically in the game. An example of this would be a function that eats food automatically for you when your hunger bar gets low enough. The player will win the game if they can successfully get through all of the prompts without letting the hunger bar fall to 0. However, if that hunger bar reaches 0, it's game over. The value of each resource affects the rate of change of the other resources, so time and resource management is key to succeeding.
Let's talk about the visualizations. The visualization mainly have 3 different categories: the base game statistics, the change in the value, and the countdown timer. In one of our earliest design iterations, we chose bar graphs for the base game statistics because it conveys the idea pretty effectively. We also layered the countdown timer and the value change indicator at the bottom of the command prompt. In practice though, it doesn't look so good. The graph is way too big, and your focal point will probably always be on the graph. Whenever you want to look at a prompt, you probably need to move your eye from the bottom right all the way to the top left, so overall it's a pretty bad idea. In later iterations though, we took all the 6 graphs and squeezed them into a single line on the right of your command prompt. We moved the timer to the bottom of your graph, and finally used white boxes to indicate how the values would change over time. This way we maintain the visual clarity of 3 different graphs, but also make it very compact and allow you to focus on writing your own code. We also had extra spacing on the right, so we added in spark lines that indicate how the values change over the last 5 prompts. Finally, we gave everything an overhaul and changed them into an 8-bit style so it looks more like playing a game.
We received great feedback from our playtesting sessions. In particular, we were glad to see some of our goals being correctly interpreted by the participants, as well as some expected and unexpected results. Our survey results revealed that for the most part, we introduced live feedback quite well to the playtesters. It should be noted, however, that many of our testers appeared to skim the text, resulting in a higher learning curve. Additionally, the playtesters were able to clearly see the consequences for each choice. Many playtesters had concerns remembering certain commands and other indicators, so there's room for improvement in the game's user-friendliness and explanations. Multiple playtesters indicated a desire for alerts or notifications for low statistics and successful or failed automation attempts. As many playtesters mentioned the lack of commands to automate, something to add in future iterations might be to implement more complex interactions between statistics and commands. The game itself could have a unique programming language instead of JavaScript, which has the potential to avoid function name conflicts, among other things. Much more depth could be added to the game by including branching story paths. Not only would this add additional replayability, but also more emphasis on the choices the player makes. Finally, future iterations should carry out an official experiment with different amounts of visuals to show conclusive evidence of impact on the player performance. Thank you for watching!